Thank you very much. I'm really happy to be here. I need to correct one thing about that bio that sounds like it's probably an old bio. It's been a while since I've worked with SpringSource. We are now at Object Computing Incorporated, based in St. Louis, Missouri. That's the new home of the Grails project. That's an announcement that we just made just earlier this month, just a few weeks ago. We're really happy about that, really optimistic about some great things we're going to be able to do with the framework. But OCI, Object Computing Incorporated in St. Louis, Missouri, is the new home for the Grails web framework. And the Grails web framework is what I work on. That's what I've been doing for the last maybe 8 years or so, is focusing pretty much exclusively on building the framework. So we will continue to do more of the same. But OCI is where all of that is happening now. So thank you all for having me. What I'm going to be talking about this afternoon, at least in this session, is metaprogramming with the Groovy Runtime. There are really two kind of fundamentally different types of metaprogramming that Groovy supports. And the two broad categories there are the runtime. There's a lot of really powerful, really interesting things you can do at runtime with Groovy, and that's what I'm going to talk about for the next hour or so. And later today, I've got another session, part 2 of 2. This is really part 1 of 2. Part 2 of this session is metaprogramming with the Groovy compiler. So in this session, I'm going to focus on runtime metaprogramming. In the second session, I'm going to focus on compile time metaprogramming. And after having covered both of those, so at the end of the compile time metaprogramming talk, if we've got a little bit of time, we'll sort of revisit some of the runtime metaprogramming stuff that I'm going to talk about in this session. And having discussed both of them, we'll be able to weigh kind of the pros and cons of one versus the other, and why you might choose runtime metaprogramming and why you might choose compile time metaprogramming. It's really not one or the other. In the general sense, they're both really powerful techniques, and there are some things that you'll want to do at runtime and some things you'll want to do at compile time. But to get the discussion started, I'm going to start with runtime metaprogramming. That's really what we're going to focus on for the next hour or so. My Twitter handle is listed there at Jeff Scott Brown, and my email address is brownj@ociweb.com. Feel free to use either of those to contact me. If you've got questions during the session here, please raise your hand. The lights are really bright, but I can see most of you. But certainly questions during the session are welcome, and the more interactive we can make this, maybe the more interesting it'll be. So I'm going to jump right into it. I'm going to start by asking how many of you are already doing Groovy development? All right, very good. So Groovy is a really powerful dynamic language for the JVM. It's so there are several things there, right? Groovy is a language. It's a programming language. Groovy is a dynamic language in particular, and that the dynamic nature of Groovy is what enables everything that I'm about to talk about. So lots more on that to come. So it's a dynamic programming language, a dynamic programming language for the JVM. Groovy specifically targets the JVM. So if you're trying to build applications to target .NET or some other platform, Groovy is not going to help you with that. Groovy specifically targets the JVM. So I'm not going to spend a whole lot of time talking about Groovy in general. I want to get right into the details and talk about particulars of Groovy. And in particular, I want to talk about Groovy's runtime metaprogramming capabilities. So one of the first things that we need to cover is what is metaprogramming. And metaprogramming is one of these terms that means different things to different people in different contexts. So I want to kind of narrow in on the kind of metaprogramming that I'm talking about in this session. So the kind of metaprogramming that I want to cover in this session is we're basically talking about a program modifying itself while it's running. That sounds pretty crazy, and that is pretty crazy. But we're going to see what that really looks like and get a sense for some of the capabilities that Groovy offers in its runtime metaprogramming environment or capabilities. So we'll get in the short amount of time we've got, I'll be able to demonstrate some of the basic runtime metaprogramming capabilities that the language provides, and also talk about some practical ways why you want to be able to take advantage of some of those features that I'm going to talk about. So Wikipedia says something about metaprogramming. It defines metaprogramming as the writing of computer programs that write or manipulate other programs or themselves. And that's close enough to what I'm going to be talking about today. We're going to be focusing on the kind of metaprogramming that is going on when a program is running and the program is modifying its own program space to change how the program is going to behave from that point forward. All that is going to make more sense as we start jumping into some of the details. Yes, sir?
I had a question. So with this help us create DSS, this metaprogramming thing which you're going to talk about, is it going to help us understand how to create DSS?
Yeah, so the question is the kind of metaprogramming that I'm going to talk about, does it relate to building DSLs or domain-specific languages in Groovy? And the answer is absolutely. So we're going to look at some specific examples of that. So hold off on the details there, but absolutely. Groovy's runtime metaprogramming capabilities definitely lends itself to building DSLs. That's a really good question. So Groovy lends itself really well to metaprogramming. As I said before, Groovy is a dynamic language, and the dynamic aspect of Groovy comes in, sort of manifests in a number of different ways. One of the important ways that Groovy is dynamic is in its dynamic dispatch mechanism. So there's a part of Groovy called the MOP, or Meta Object Protocol. And the MOP is this kind of subsystem inside the Groovy runtime that is responsible for handling pretty much all of the interactions that go on between your objects. Right? So if you create an object and that object has a reference to another object, and the first object invokes a method call on the second object. Right? So you've got two objects. One of them is invoking a method call on the second object. That method call is handled by the MOP. And there's a whole lot of stuff that can go on as part of handling that method invocation, and that's what I'm going to drill into here. But it turns out that Groovy lends itself really well to metaprogramming because of its dynamic dispatch mechanism, all the stuff that the MOP is handling. So this is almost true. It's true enough for our purposes for this talk. I'm going to say that every method call that you make from Groovy is really a request to the MOP. You're sending some information to the MOP. You're saying, here's a reference to an object. Here's the name of a method that I want to invoke. And maybe here are some parameters that I want to pass to that method. Go make that happen. And the MOP is responsible for making that happen. And you get to write code that participates in that handling. And that's how you tap into Groovy's runtime metaprogramming capabilities. So Groovy allows you to do things like intercept method calls. You can create methods at runtime. You can replace existing methods at runtime. So while the program is running, you can replace methods. There's all kinds of really cool stuff that you can do at runtime in the JVM that the Java programming language doesn't provide a mechanism for you to tap into. The JVM is capable of all kinds of really powerful dynamic stuff that the Java programming language isn't really designed to provide easy access to. And Groovy takes advantage of a whole lot more of the dynamic capabilities offered by the JVM than a language like Java does. All right, so let's just start looking at some code. So inside of Groovy, in the standard Groovy libraries, there's a class called Expando. And the code that you see here, it kind of highlights some of the simple things you can do with an Expando object. So we'll just step through this top to bottom here. So the first line of code there is creating an instance of the Expando class. The second line of code is assigning a value to a property on that Expando instance. So my Expando.favoriteLanguage equals Groovy. It turns out there are more interesting things going on with that one line of code that might be apparent. So we're going to tease that out here as we're going to start writing some code and we'll understand what that really means. But for now, I'll just point out that the Expando class does not have a property called favorite language. If we looked at the source code for the Expando class, that's a real class that's provided by Groovy. If we looked at the source code for the Expando class, we would see that there is no favorite language property. But somehow, I can assign a value to that property, and it just works. We're going to tease out how that works over the next few minutes. The next line of code is doing the same kind of thing. We're assigning a value to a property, but whereas my Expando.favoriteLanguage equals Groovy, the value that we're assigning to the property is the string Groovy. On the next line of code, my Expando.addNumbers equals, and then what you see on the right-hand side of the equals there, is fundamentally the same thing as the previous line. We're assigning a value to a property, but the value is something special in this case. It's a closure, right? So Groovy has support, and it has always had support for closures. Java now has support for lambdas in Java 8. Groovy's always had support for closures, which have a whole lot of things in common with lambdas. But for our purposes, let's just say that a closure is a block of code. And that block of code may or may not accept parameters. Just like when you define a method in Java, that method might accept parameters or it might not accept parameters. In this particular case, the block of code does accept parameters. It accepts 2 parameters. So the parameters are called I and j, and then you see the arrow operator there. That marks the end of the argument list, and then you have the body of the closure, or think of it as having a lot in common with the body of a method. Right, so I can put anything I like in this closure. It turns out this closure simply accepts 2 arguments and then adds their values together. And return statements are optional in Groovy, so that could say return I plus j, but instead it just says I plus j. So the result of adding j to I is what will be returned from this closure. And then there's some assertions. So the first assertion there asserts that when I retrieve the value of my expando.favorite language, that it equals Groovy, right? Because we assigned favorite language the value Groovy earlier on. So when I retrieve that value, it should be Groovy. The next assertion is maybe a little bit more interesting. There I'm asserting that when I invoke a method called addNumbers, right? There is no addNumbers method in the expando class, but somehow I can invoke that method called addNumbers, a method that doesn't exist, and pass in a 60 and a 40 as an argument. And what I expect to get back is 100, right? So it turns out when I call addNumbers there, the closure that we assigned to addNumbers earlier in the code there, myexpando.addNumbers equals closure, that closure gets executed. 60 is being passed as the first argument, and 40 is being passed as the second argument, and what we get back is the sum of those arguments, which of course would be 100. And then the last assertion simply asserts that if I retrieve the value of a property that does not exist, that won't throw an exception, or we won't have a failure condition. That property that doesn't exist will simply evaluate to null. And all 3 of those assertions do pass. So the expando object really does behave the way that we've described here. So let's introduce another couple of ideas, and then I'm going to jump into an IDE and start writing some code, and we'll understand how all this works. One thing that I want to point out and be explicit about is this is not the way that all objects in Groovy behave. It's not the case that in Groovy you can just create an instance of any object and just make up properties and assign them values. That's not the case. That's not how objects generally behave in Groovy. There's code specifically in the expando class to allow this kind of behavior, and it's that code that we're going to drill into. We're going to write our own version of expando in a minute, and we'll understand how all of that works. So you have a question? Yes, the question is, how does this work? Well, what is so special about the expando class? And we're going to drill into that, and we're going to understand how all this works. But I want to be clear, this is not how all objects behave. So whoever wrote the expando class has to have added specific code to the expando class to allow it to behave this way. Yeah, so the question starts with a comment that in Java you can't add methods to classes at runtime, and in Groovy you can. And or how does Groovy relate to Java's inability to do that? It turns out that you can add methods to Java classes at runtime. I'll demonstrate that in a little bit later. You just can't do it from Java. You can do it from Groovy, and you can interact with those methods from Groovy, but you can't interact with them from Java. So if we've got time towards the end, maybe I'll tease out a specific example to highlight that. But you can, in fact, add methods to Java classes at runtime from Groovy. And as I said, we'll demonstrate that later. All right. So let's get back to the MOP that I mentioned earlier, the Meta Object Protocol. So every time you assign a value to a property, you're really sending a request to the MOP that says, here's an object, here's a property that the name of a property that I want to assign a value to, and here's a value. and then a number of things might happen to satisfy that request. So for example, when code like expando.favoritelanguage equals groovy, when code like that is executed, that request is sent to the mop, and the mop might do a number of things. Well, one thing the mop might do is it might discover that there is a property called favorite language in the expando class. In our case, there's not, but there might be a property in the expando class called favorite language, and the value groovy simply would be assigned to that property. In our case, there is no such property. Another one of the things that the mop might do is it can look in the expando class to see if there's a method there called setProperty. And if there is a method there called setProperty, the mop will invoke that method and pass as the first argument the name of the property that we're assigning a value to, and as the second argument, the value that we're assigning to it. So when you write expando.favoritelanguage equals groovy, at runtime, it's what actually could happen is that can be a call to expando.setProperty favorite language comma groovy. Right? You would never write the second line of code. You'd always write the first line of code. But the second line of code, depending on a number of factors in the runtime environment, the second line of code might be what's actually happening. Again, we're going to demonstrate that in some real code in the IDE here in just a minute. Likewise, when you retrieve the value of a property, one of the things that the mop might do is it might invoke a method called getProperty and pass the property name as an argument, in our case, favorite language. And getProperty can return whatever it wants to return. And again, we'll write some code that takes advantage of that as well. And then finally, when you invoke a method like expando.addNumbers 33, 66, there are several things that might happen if that method does not exist. A method named invokeMethod might be invoked if that method exists. So if you wrote a class that has an invokeMethod in it, then you can create an instance of that class and call addNumbers on it and pass arguments. Even though there's no addNumbers method in your class, that method call can still work because the runtime may call the invokeMethod method and pass in information like the name of the method being invoked and the values of parameters being passed to that method. All of that will make a lot more sense in some real code. So let's take that step here. So I'm going to jump into an IDE here, and I'm going to create a brand new class that I'm going to call GIDS Expando. All right, we're going to pretend that the Expando class does not exist, and we want to write our own version of the Expando class. And we're going to be good developers. Everyone here saw Scott Davis's talk this morning on writing good unit tests, and we're going to be good citizens here, and we're going to write a unit test. So we're going to write GIDS Expando spec. Right? We're going to take advantage of a really super slick unit testing framework in Groovy called Spock. Specification one. Oh, I'm in the wrong project here. That makes sense. I was in a project that I was not in the project that I thought I was in. All right, so now we'll create the GIDS Expando class right there, and we'll create the GIDS Expando spec over here. All right, so we're going to do test-driven development here. Test property access. I'm going to write a Spock spec that describes how I think the GIDS Expando class should behave. I'm going to say, given a new GIDS Expando object, when I do something like that, then I expect ex.favoriteConference to be equal to GIDS. All right, so we've written a spec that describes one piece of behavior that the GIDS Expando class should support, and that is I should be able to make up a property, any property I like favorite conference, and assign it a value, and then later if I retrieve the value, the value that's returned should be what I expect. In this case, I'm assigning a value to the favorite conference property, and the value that I'm assigning is GIDS, and then I expect the value of ex.favoriteConference to be equal to GIDS. And if I run this test right now, it should fail. There we go. And we got a missing property exception, no such property, favorite conference. This line of code right here is throwing an exception, and we expected it to throw an exception. Yes? I'm sorry, say that one more time. So the question is about the fact that I'm referencing a variable that doesn't exist, right? Favorite conference. That's right. We are referencing a property that does not exist here, and somehow we're going to make that work. Right now it's not working. We're going to add some code to the GIDS expando class to make this work, but right now it's not working. So when we refer to something that, generally in Groovy, if you refer to a property that doesn't exist, you'll get a missing property exception, and that's what's happening in our test right now. We're going to add a very little bit of code, like 3 lines of code to the GIDS expando class, and we're going to make this test pass. Once I get that operational, if that's still not clear, let me know and we'll tease out the details. But let's get this test to a point where it passes. So right now we're creating an instance of GIDS expando. We're assigning a value to a property that doesn't exist. We're trying to retrieve the value of that property and assert that it has the value that we expect. Right now, when I run the test, we get a missing property exception because this line of code right here is referring to a property that does not exist. Remember that one of the things the mop might do with this is it might call ex.setProperty favorite conference GIDS, right? So we're going to add that setProperty method to the GIDS expando class and allow line 13 here to work, to not throw an exception. So if I did something like void setProperty, string property name, and a value, there. So that method will be called anytime I assign a value to a property on an instance of GIDS expando. And then the other way around, I can say getProperty. GetProperty will be invoked to retrieve the value of a property. So setProperty is used to assign a value to a property, and getProperty is used to retrieve the value of a property. So let me type 3 lines of code here, and then I'm going to back up and talk about what's going on right here. All right, I'm going to come back to that code. Let's just run our test and verify that we've got this thing operational so far. And we do. I got a green bar. Our test passed. I can do something like this. I live in St. Louis, Missouri, in the US. All right, so that should still work. And it does, green bar. So I can just keep making up properties and assign them values, and I'll be able to retrieve the values. So let's take a closer look at the code that I just wrote in the GIDS expando class and understand what's going on there. So remember, the 2 things that we're doing in our test is I'm assigning values to properties that do not exist, and I'm retrieving the values of properties that don't exist. And the way that I made that work is, as the author of the GIDS expando class, I put a setProperty method and a getProperty method in that class. So anytime I assign a value to a property that doesn't exist, this gets called. And anytime I retrieve the value of a property that doesn't exist, this gets called. So I added a private variable in the GIDS expando class called props. I can call that anything. There's nothing magic about the word props. It's just a variable name, could be anything. This is Groovy's sort of literal syntax for creating an empty map. I could also have done this. Right? It's the same thing. It's actually a linked hash map, like that. So the value of props is just an empty map. I'm going to go back to using Groovy's syntax because it's groovier. Right? So the value of props is an empty map. So I create an instance of GIDS expando. Inside that expando is this empty map, and I assign a value to favorite conference. ex.favoriteConference equals GIDS. There is no favorite conference property, but the Groovy runtime environment recognizes that this setProperty method exists. So Groovy is going to call that setProperty method and pass favorite conference as the property name and pass GIDS as the value. And what this is doing is simply putting an entry in the map The map is just a container to hold on to all these dynamic variables. So I'm putting an entry in the map where the key is prop name, favorite conference, and the value is val, which is GIDS. So now the map has one entry in it. The key is favorite conference, and the value is GIDS. Then we executed ex.hometown equals St. Louis. And then the same sort of thing happened, right? Set property is called again, where prop name is hometown and val is St. Louis. So now the map is getting bigger. I've got two entries in the map. The keys are favorite conference and hometown, and the values are GIDS and St. Louis. Then later, when I retrieve the value of the favorite conference property, get property is invoked, and the name of the property whose value I'm trying to retrieve is passed as an argument. So get property is invoked with favorite conference as an argument. And remember that return statements are optional in Groovy. I can leave the return statement off. But what's being returned from this method is the value in the map that's associated with the favorite conference property name, right? So when I retrieve the value of favorite conference, this method gets called, and what this method is returning is the value in the map that's associated with the favorite conference key. All right. Any comments or questions about that? Good. Let's add one more feature to the Expando, and then we'll press on. More test-driven development, of course. So we're going to test another feature that we want the Expando to support. ex.addNumbers equals A, B, and C. We'll just add 3 numbers there. That looks good. All right. So on line 26 there, I'm assigning a value to a property that doesn't exist, right? The property is add numbers. There's no magic about the words add numbers. It's just the name of a property. Could be Jeff, right? I can call that property anything. So I'm assigning a value to the add numbers property. That property doesn't exist. And the value I'm assigning to that property is a closure in this case. So contrast line 26 with line 13. Right? On line 13, I'm assigning a value to a property that doesn't exist. And the value I'm assigning is a string. Right? GIDS on line 13. On line 26, I'm doing the same kind of thing, right? I'm assigning a value to a property that doesn't exist, but instead of the value being a string, in this case, the value is a closure. But this is going to call set property just like line 13 is calling set property. Set property is being called, add numbers is the first argument, and this closure is the second argument. So this will work for the same reasons it works for the other two properties. When I call ex.addNumbers equals closure, set property is called, add numbers is the property name, and the value is a closure. So I'm putting an entry in the map where add numbers is the key and the closure is the value. Then later, my test is invoking a method called add numbers and passing 40, 25, and 35 as arguments, and I'm expecting 100 to be returned. It turns out this test is not going to pass right now, so let's see it fail, and then we'll talk about why it's failing. Right? So the test failed. Got a big red bar. We got a missing method exception. No signature of method add numbers. Blah blah blah. This right here is throwing an exception. In particular, this part is throwing the exception. Lines 26, 27, and 28 were fine. Right? We already have code in the GIDS Expando class to support that. It's the invocation of the add numbers method that threw the runtime exception, right? There is no method called add numbers in the GIDS Expando class. There are a number of ways that we could handle that method call in the GIDS Expando class. I'm going to do just the simplest the thing I can do with the least amount of code here. And that is I'm going to add a method called method missing to the class. Method missing is a special method, just like set property and get property are special methods to Groovy. Method missing is a special method. What method missing is about is, as the author of the GIDS Expando class, if I put a method missing method in the class, what that means is some other part of the system. So maybe I'm writing a library, and maybe the application that's using my library can create an instance of this GIDS expando class and invoke any method at all. Doesn't matter, any method at all can be invoked on an instance of that class. And if the method doesn't exist, instead of throwing a missing method exception, which is what happened a moment ago when I ran this test, instead of that happening, Groovy will invoke this method to let the GIDS expando class know that someone tried to invoke a method named add numbers, and here are the arguments that were being passed to the method, and the GIDS expando class gets to decide what it wants to do with that. So let's add about 3 more lines of code here. Let's see, if prop is a closure, all right, let's run our test. Make sure this is passing, and then we'll look at that code that I just wrote. Okay, the test is passing now. So when I invoke EX, or when I call EX.addNumbers and pass several numbers as arguments, the Groovy runtime looks to see if there's an addNumbers method in this class, and there's not. So normally what would happen at that point is a missing method exception would be thrown. But before throwing a missing method exception, Groovy will look to see if there's a missing method in this class, and there is. So that method gets invoked. So method name, the first argument here, is addNumbers, and args, it's really an array. I don't have to statically type it like that, but that's an array that includes all of the arguments that were passed to this method. So now the GIDS expando class gets to decide how to respond to this method. So and I'm going to do a little bit of hand waving over this. I don't want to spend a whole lot of time talking about the 2 or 3 lines of code here. I'll just briefly describe it, and then I want to press on. There's a little bit of, there's important stuff going on here that it's important, but not what I want to focus on this afternoon. So what's happening on line 16 is we're retrieving a value from that map. It's going to be the closure that we assigned to the addNumbers, right? We said ex.addNumbers equals closure. The value of prop here is going to be that closure. And then we're going to invoke the closure, pass the arguments into the closure. There's a little bit of magic going on around that asterisk that is what I don't want to get distracted with right now. But basically, we're retrieving the closure from the map and invoking the closure and then returning whatever the closure returns. So here, when I call ex.addNumbers, that really calls method missing. Method missing is going to grab this closure out of the map, invoke the closure, and return whatever the closure returns. So the closure is going to return the sum of those 3 values. And again, I want to do a little bit of hand waving over some of the details there just because it's distraction from what I want to focus on. But what we've done is we've recreated the behavior that the real expando class has to offer, right? All this stuff that the expando class is capable of doing, now our GIDS expando class is capable of doing. This is all stuff that you can't do in a statically dispatched language like Java, right? How do you write a class in Java such that you get to just make up properties and assign them values, and you get to invoke methods that don't exist? You can't do that, right? The code won't even compile in Java. In Groovy, the code does compile, and you get to do really powerful, interesting things with those interactions at runtime. So there are interesting things you can do with the expando class, but let's just think about kind of at a high level what I just did to the expando class and think about really practical ways to take advantage of that. So inside the Grails framework, everything I've talked about so far, none of it is Grails specific. This is all Groovy language stuff. So Grails is this really powerful and flexible web framework that we built with Groovy. And Grails allows you to do things like if you have a domain class in a Grails application that looks like this. Right, so you've got a class called person has a first name, and a person has a last name. Right? That's the entire source code of the person class. You don't write any more code than that. Somewhere in your application, if you wanted to send a query to the database to retrieve all the persons whose last name was something, you could do something like this. Person.findAll by last name Brown. So line 7 there is invoking a method that does not exist in the person class. Right? There is no method called findAll by last name, but somehow that method call will work inside of a Grails application. And what that method call does is it sends a query to the database, and that database could be Oracle, it could be MongoDB, it could be any of a broad range of data stores. What that method is going to do is send a query to the database to retrieve all the person instances whose last name is Brown. That's a really expressive, really powerful way to express a query. That's made possible by the stuff, in part, by what I just demonstrated. Right? So in this case, we didn't have to write the method missing method in here. Grails adds that method to the person class on your behalf. Right? That's something that the framework does for you. Which involves the second piece, one of the other big pieces of this that I want to talk about. So what we've seen so far is just a couple of hooks like set property, get property, and method missing that allow you to write code that interacts with property access and method invocations at runtime. What we haven't seen yet is how you add methods to classes at runtime. So I'm going to demonstrate that, but for now I'll just say that can be done, and it's pretty easy to do. And if we tie those two things together, if we know how to intercept method calls at runtime, and we know how to add methods to classes at runtime, what we can do is tie those together. So at runtime, we can add a method to the person class called method missing, and have that do all the complicated stuff to intercept this method call and send a query to the database and return the results and so forth. Questions or comments about any of that so far?
This is also the foundation for GORM.
It is, in fact, the question is this the foundation for GORM, right? GORM is this really powerful, flexible ORM thing that we've built inside of Grails, and absolutely, it takes advantage. This is how a lot of the stuff in GORM works. That dynamic method, that dynamic finder that I just demonstrated, person.findAll by last name, that method is added. The capability of invoking that method is provided by GORM, and GORM is doing all this metaprogramming that we're talking about. You don't have to write any of the metaprogramming code in your Grails app. You just write the person class. GORM does a bunch of really powerful metaprogramming stuff to add capabilities to your person class, like find all by last name, and find all by first name, and find all by first name and last name, and there are lots and lots of interesting combinations of things. All right, let's press on. Closure delegates. So let's jump back into our IDE here. And I'm going to create another class that I'll just call demo. Make sure that's operational there. Okay, we're in good shape. All right, so if I create a closure, I'll call C. Like that, and I run this class, nothing interesting is going to happen. Right? The program just ran, it's done, nothing happened. What I've done here is I've defined a closure. A closure, we'll just say, is a block of code. Right? I've got this block of code, but I never invoked that block of code. So now if I do that, we'll see hello Bangalore, and if I do that several times, we'll see hello Bangalore over and over and over again. All right. So the value that I'm assigning to C there is a closure, right? Groovy has first class support for closures. Closures are a really, really powerful part of the language. They're an important part of Groovy's whole story. So on lines 6, 7, and 8 there, I've defined a closure that just calls println and passed assigned that closure to a variable called C. So C is a reference that points to that closure, and then on lines 10 through 13, I'm invoking that closure over and over and over again. All right, so now if I were to do something like this, instead of calling println, if I said add numbers 4, 3, and 6, we'll simplify this, get rid of some of those invocations. And run this, we're going to get an exception. This is not going to work. Right? We get a missing method exception, no method called add numbers. Right here, that line of code is problematic at runtime. There is no method called add numbers, so I can't invoke that method. Let's do this. I'm going to move this code into an instance method. That's going to simplify a couple of things I want to do. All right, so we're going to have the same problem we had just a moment ago. I haven't really changed anything. No signature of method add numbers. All right, let's say append. Hello, append Bangalore. All right, so when I run this code, the closure gets executed, and the closure is trying to invoke a method called append. There is no method called append, so we get an exception. If I define a method called append, like that, now we won't get an exception, unless I've got a typo someplace. Okay, so when line 10 is executed, we're invoking a method called append. In Groovy, the parens are optional, right? So I'll make it look a little bit more like a method call. We're invoking a method called append and passing hello as an argument. So that's calling this method, and all is well. If I get rid of that method, so we'll just leave it commented out for now, and run the same code, that's when we get the missing method exception. We're invoking a method called append. There is no such method, so we get an exception. Yes, there's a question?
Take out the call to the closure. Will there be any error?
If I take out this line of code, yeah, there will not be an error here because lines 12 and 13 never get executed. I've defined a block of code that if that block were ever executed, it would throw an exception. But since I've commented out line 16, the block of code's never, so I can put almost anything in here, right? I can just do that. It's okay until I try to execute that code.
But this can be changed using the compiler. I think this is one of my personal blocks when I look at this, right? I mean, you get to know only at runtime. So you could change this in the compiler setting?
You can't. The question is, can you change this in the compiler settings? It's not really a compiler setting, but there are things you can do to turn on static compilation with Groovy, and that's really powerful, really cool stuff, but not something we've got time to get into, so just in like 20 seconds. When you're compiling your Groovy with static compilation enabled, the Groovy compiler will enforce that all of your method calls are valid, and it will complain if they're not. But there are lots of times when you don't want that. There are lots of times when you want to be able to invoke methods that don't exist because you know there's something in the runtime environment that's going to handle that method call. And I'm happy to talk in lots more detail with you about that later, but I'd like to press on here and get this demo operational. So for now, we'll say that I can invoke almost anything at all here, and the code will compile, right? That code compiles. It just won't run because there is no method called ASDF, so forth. Likewise, there is no method called append. All right. I'm going to create a string buffer. All right. Let's run this and see the output, and I'll talk about what's going on here. All right, so the output here says string buffer value is hello Bangalore. So let's figure out what's going on there. So I created a string buffer at line 9, but I never interacted with it. I never called any methods on the string buffer. We don't see sb.append here, right? I'm not explicitly calling the append method on the string buffer, but somehow these strings are making their way into the string buffer. And that somehow is really this one line of code right here at line 16. So every closure has a delegate associated with it. Every closure has a delegate associated with it. And you get to assign a value to that delegate if you like. And that's what we're doing on line 16. So on line 16, I'm setting the delegate on this closure to be a string buffer that I created on line 9. So what the role that the delegate gets to play is when the closure is executing, the delegate gets an opportunity to respond to method calls and property accesses that are made inside the closure. So when line 12 and 13 execute, and I call append hello, append Bangalore, the delegate gets an opportunity to respond to those method calls, right? So it's as if I did this, sb.append, we'll get the same behavior, but I don't want to refer to SB. We'll see in a minute, kind of when we back away and look at this in a more practical context, that often this closure is being authored in one context, and the delegate is being created and assigned in another context, and the two don't know about each other, right? So imagine we're writing this closure, and I just want to call append inside the closure, and I don't know how that's going to be handled. I just know something will handle it. And it could be that a string buffer is going to handle it. It could be that those strings get written to a database. It could be that, so we're not concerned with the details of what append really means. We just know we can call append and pass strings, and the delegate will be responsible for deciding what that means or what to do with the strings as they're appended. So if I comment out line 16 here, this will not work, right? We'll get an exception because there is no append method. And when I enact or enable line 16, now we're back in action where those calls to append are really being redirected to the string buffer. If we come back over here and look at this code example. So here, say we're in the context of a Grails application, and user is a domain class. So domain classes in a Grails app are classes that you're going to create instances of and persist to a database. One of the things you can do in a domain class inside of Grails is you can declare a static property called constraints and assign that constraints property a closure. And then inside of that closure, you get to execute, it's a DSL, for defining what are valid values for properties in this domain class, right? So the login has to be at least 5 characters and no more than 15 characters. It cannot be blank, and it has to be unique. I can't have 2 users with the same login. The password has to be at least 5 characters and no more than 15 characters, and so forth. So I've got a DSL for describing the rules about what are valid values for these properties. So let's think about the code what's inside of that closure there. We're invoking a method called login and passing these named parameters as an argument. There is no method called login, right? There's no method called login any place in this code. There's no method called password or email or age. But this DSL allows me to use the syntax that you see there to describe what are valid values for these properties. And somehow Grails allows all that to work. And we've seen kind of the broad strokes of the pieces of the puzzle that it takes to make that happen, right? What Grails is going to do with this is it's going to grab that closure and execute it. But before executing the closure, well, if Grails just grabbed that closure and executed it, missing method exceptions would be thrown because there is no login method, there is no password method. What the framework is doing is grabbing that closure and assigning a delegate to it. So the delegate gets to respond to that call to log in and password and email and age. And that delegate has a whole bunch of complexity in it that knows how to deal with these parameters that are being passed. And it knows how to configure the database so that the login column will only be 15 characters wide. And it knows how to impose all the rules that are expressed in this DSL here. But that delegate is responding to the login method and the password method and the email method and the age method. But that delegate is a class that's provided by the framework, right? The code we're looking at here is code that you've written in your application. Somehow the framework is able to respond to these method calls. So it might seem like there must be some class inside of Grails that has a login method and a password method and an email method, but that's not the case. Login, password, and email are property names that you made up as the application developer, and somehow we're able to intercept those method calls. And that somehow is the method missing business that we just looked at, right? So inside of Grails is a class whose name you don't care about. Inside of that class is a method missing method, right? Grails is creating an instance of that class and assigning that instance to be the delegate of this closure before the closure gets executed. So when the closure is executing and that first line of code is invoked, login parameters, the delegate gets an opportunity to respond to that method call. The delegate is an instance of a class inside the framework. That class does not have a login method, but it does have a method missing method in it. So that method missing method gets invoked. And as I said, there's a bunch of complexity inside of there that knows what to do with all these parameter values. But all of that metaprogramming and the closures and the closure delegate stuff all kind of conspires together to make it possible for the application developer, the person writing this code, to take advantage of this DSL capability, right? As the application developer, I want to define that my application has a domain class called user. These are the properties that a user has, and here are the rules that describe what are the valid values for those properties. And I don't care how it happens. It's the framework's responsibility for imposing those rules. But Groovy's metaprogramming capabilities are what make this DSL possible. Yeah?
You say the constraints you are having for properties, right?
What do I call what as in particular? Right? That's right. So those are method calls, right? We're invoking a method called login and a method called password. Those are methods that don't exist, right? But they're being handled by the method missing method inside of the delegate that I just described. And that thing, the method missing inside the delegate, will look at the parameters like length : 5 ... 15. And the delegate knows what to do with that. One of the things the delegate's going to do with that is it's going to go off to the Hibernate configuration stuff and configure Hibernate to know that the login will never be more than 15 characters long. So Hibernate can do some smart stuff, like when it creates if it creates a column in the database for to store the login, it will only create it'll create a column that's only 15 characters wide instead of whatever the default is. But all that complexity, you're not interacting with Hibernate at all when you write this class, right? You're just writing a class where you get to take advantage of this DSL and describe these rules, and then it's up to the framework to turn this simple code into something, or deal with this simple code to manage a whole bunch of complexity on your behalf. That's the reason this DSL exists, is so the application developer writes something very simple. The framework is responsible for doing a bunch of tedious stuff with this code, and Groovy's metaprogramming, method missing, enclosure delegates, the stuff that we've been talking about, all of that kind of conspires together to make this even possible.
This does not look like a typical method invocation, right? It's not even a map. I mean, it looks like a map, but it's not even a map. What are
Yeah, so it's not a schema object. Those really are method calls, right? We're invoking the first line of code right here. We're invoking a method called login, and we're passing named parameters. It's really a map, but we're invoking a method called login and passing some stuff as an argument. So it doesn't really matter if that looks like a method call or not. That is, in fact, a method call in Groovy, and that method call is being handled by all the stuff that I just described. Yeah. Other comments or questions about that? All right. We've got just enough time to demonstrate one more small piece of this puzzle. And I'll do that in code rather than slides. So there was a comment earlier about adding methods to Java classes, and maybe that's possible, maybe that's not. Turns out that it is possible, and we've got less time than I thought. We've got 1 minute. So I'm just going to demonstrate this really, really quickly, and then we'll wrap it up, and I'll be happy to take questions for you. All right, so the string class has been written in Java, right? That's java.lang.string. There's nothing Groovy about it. It's not a class that's provided by Groovy. String is the class that's the same java.lang.string class that Java developers are used to interacting with. We're not talking about a special Groovy string class. I'm talking about the standard string class that you're used to dealing with. So if I said, I'll statically type this just to be clear. Scott Brown. I'll invoke that a few times. And run this just to demonstrate that it worked, right? I'm invoking a method called doSomething on an instance of java.lang.string, right? There is no method in the string class called doSomething, at least normally there's not. But this code right here is adding a method called doSomething to the string class. So the string class, the class right here, could be any class at all. It could be a Groovy class, a Java class, a Scala class, a Clojure, any class at all that's available from the JVM. I can interact with that class from Groovy and do things like add methods to that classes, add methods to those classes, and this is doing that. So in the we're really out of time already, so I don't have time to really describe what's going on there. I just wanted to quickly demonstrate that it's really simple to add methods to classes, and it doesn't matter if that class is written in Groovy or Java or what language the class was written in. The syntax and the approach that you use for adding methods to classes is exactly the same in all of those cases. In this case, we're adding a method to a class that was written in Java, but if that class were written in Scala or Clojure or Groovy, this syntax would look exactly the same. I'm sorry? Even existing methods, right? So you can use that same approach for replacing existing methods. So if the string class did have a method called do something, and I wanted to replace it with my own, that approach, what I just did, would do that. And there's a lot of details around that and things you have to be careful about that we just don't have time to get into right now. You can add method missing, and that's how the Gorm stuff works, right? So Grails uses that class name .metaclass that approach to add a method missing to all of your domain classes. So when you call person.findAll by first name, that's how all of that's tied together and how that works. So there's a whole lot more to this that we could spend the next couple of days talking about that. What I wanted to do was provide a really quick introduction to some of the key runtime metaprogramming things that Groovy provides, and hopefully that gives you a little bit of a sense for some of the capabilities. And if you have any specific questions, I'm happy to talk to you about that, but we are out of time now, so let me know if you've got questions, and thank you all for your attention.